Hello students, welcome to my class. Today we are going to discuss few questions related to NEET exam. Clear friend? So let's start with the topic, that is question answer round. Now look at the first question, read the question carefully, wait for a moment. Consider the following equation. For this K1 and K2 is given. What is the relation between K1 and K2? Okay friend, what to do? First of all, if I write like this, K1 expression for first, that is the concentration of SO3 upon the concentration of SO2 into concentration of O2 power 1 by 2. This is the expression for K1 for first equation. Now for second equation, that is the expression, that is SO2 to the power 1 by 2 into O2 is 2, not 1 by 2, put here 2, clear. Now upon SO3 to the power 2. Now by looking at this expression, what is the relation between K1 and K2? Look at first of all, this one is K1 and this one is K2. If I square this one, then what will happen? K1 square is equal to SO3 square upon SO2 square into O2, 2 into 1 by 2 square. This will cancel this one. This is the expression. Now if I reciprocal them, that is 1 upon K1 square, then what will happen friend? That is SO2 square into O2 divided by SO3 square. Clear to you? Now check this expression with this expression, that is 1 upon K1 square is equal to, that is K2. Clear? Or the relation find out, that is you can write like this, or K1 square is equal to 1 upon K2. You can write like this, or K1 is equal to root under 1 upon K2, or K1 is equal to 1 upon root K2. Check the expression, what I have done. First all K1 and K2. Now if I square this one, then SO3 square upon SO2 square and O2. Now if I reciprocal them, then what will happen? SO2 square O2 upon SO3. Now if I compare, this is equal to K2. Now this K2 will come here. Then what will happen? That is 1 upon K2 is equal to K1 square, root under, that is K1 is equal to root under 1 upon K2, or K1 is equal to 1 upon root under K2. So what is the expression here? That is, the expression here is B option. Clear friend? This is so simple question. I am giving you a detailed solution so that you can easily understand. After that we will discuss the short method, but this time there is no requirement to use shortcut method. I will discuss the short method during the month of Jan and Feb, that is the exam bell, in the time of exam. Wait for a moment. Now this one, look at the question. What is given? 3.1 mole of FeCl3 and 3.2 mole of NH4 SCN are added at 1 liter of water. At equilibrium, 3 mole of FeCN2 plus are formed. That is what I'm moving here. Look at T is equal to 0, Fe3 plus, that is 3.1 mole. 3.1 concentration 1 liter, this is, and 3.2 mole of NH4, 3.2 mole. Clear to you? NH4 SCN, this SCN minus comes from NH4CN, and this is 0. Now when T is equal to T equilibrium, what happens friend? That is, there is a formation of 3 mole of FeCN, formation of FeCNs are formed. That is, definitely there is a lose, that is 3 minus 1 minus 3 and 3.2 minus 3. So at equilibrium it forms 0.1 and this one is 0.2 and this one is G3. This is the expression. Clear to you? Now how to write the find the value of Kc? That Kc is equal to concentration of product upon concentration of reactant 0.2. This 10 and this one is 10 and this one is 1.5. So the Kc will be equal to 1.5 into 100, that is equal to 150. So for this question, this one is 150. Clear? Now I am going to rub this part. Wait for a moment. If you have doubt, then I am giving you alternate solution also. You can easily understand. If the expression is like this, Fe3 plus, clear friend, plus SCN minus, which gives you FeSCN2 plus. Clear? If anyone asks you to write down the expression, then if here is 3.1 mole, 3.2 1 liter concentration, so this is the concentration and this one is 0. At equilibrium, what will happen? Tell me. Sir, at equilibrium it can be written as 3.1 minus x into 3.2 minus x and this one is x. This is the expression. And in this question, wait for a moment, this x is given 3 mole and volume is 1 liter. So concentration is 3 mole per liter. Clear? So what is this value? 3.1 minus 3, that is 0.1. Clear to you? And this one is 3.2 minus 3, this one is 0.2 molar per liter and this one is 3. This is the final concentration at T is equal to equilibrium. Clear? Now put the value. K is equal to concentration of product, that is 3 upon concentration of reactant 0.1 into. Now if you solve, you will get the answer. Clear? Now I am going to rub this part and we will discuss the next one. This chapter is completely calculative. Calculation parts are included in this chapter. Now let's move to the next question. Kp and K dash P are the equilibrium constant for this reaction, that is Kp. Now how to write the expression for this expression? So Kp is equal to, that is PNS3 upon Pn2 to the power 1 by 2 and pH2 to the power 3 by 2. This is the expression for first equation. And for second expression, K dash P is equal to, tell me, that is so PNS3 to the power 2 upon Pn2 and pH2 to the power 3. Clear? Now tell me what is the relation between Kp and K dash P. Listen carefully. If we multiply this expression, then what will happen? On multiplying, then Kp square is equal to PNS3 square, squaring the both side, that is Pn2 to the power 2 by 2 and pH2 to the power 3 by 2 into 2, squaring both side. Clear? Now this will cancel this one and this will cancel this one. So Kp square is equal to PNS3 to the power 2 upon Pn2 and then pH2 to the power 3. Clear? Now tell me, compare this expression and this expression. That is, definitely you can say, so Kp square is equal to K dash P. Clear? Or Kp equal to root under K dash P. Kp is equal to root under K dash P. I am moving here. Check it out. This one, Kp is equal to root under K dash P. Clear? Now I am going to rub this part and we will discuss the next one. Wait for a moment. Wait. Now let's move to the question number 4. That is, in which of the following reaction the reaction proceeds towards completion? As we know, higher the value of K, that is the ranges, and higher the value of K favors the completion of reaction. In this case, the value, this is the complete theoretical question. K is equal to 10 to the power 3, that is the reaction proceeds towards completion. Now I am going to rub this part and we'll discuss the next one. Check it out, the next one. Look at the reaction 2A plus B is begun with concentration of A and B. Concentration of A and B is 1 molar. Okay, first of all, and the concentration of D are found to be 0.25, the value of equilibrium constant. Okay, listen carefully what I am telling. Write down the expression. Wait for a moment. 2A plus B. Clear, friend? It gives you 3C plus D. Clear? Now, when T is equal to 0, the concentration is 1 molar, this one is 1, this one is 0 and this one is 0. It is found that at equilibrium, the concentration of D is 0.25, definitely 0.25. So, concentration of C 0.25, 3 mole. So, 0.25 into 3, that is 0.75. Am I right? Yes, sir, you are right. Now, definitely there is an involvement, that is expression will be 1 minus 2x here, and this one is 1 minus x. This is the expression. And what is x? This one is x and this one is 3x. This is the expression according to the book's knowledge. Now, x 0.25, 3 into x 0.75, 1 minus x, that is 1 minus 0.25, that is the 0.75. Clear to you? And 1 minus 2x, 1 minus 2 into 0.25, then what will happen? 0.50. This is the expression. So, at equilibrium, what are the expression of this one is the first expression, this one is the second one, this one is the third one 0.75, and this one is the fourth one. Clear? If you have any doubt, you can easily approach to me. This one, this one, this one. This is the expression. Clear? I am going to rub this part. Again I am writing. If you have any doubt, use the book's formula. T is equal to T equilibrium 1 minus 2x. Clear? 1 minus x. Clear? That is 3x and x. According to the question, the x is, tell me, 0.25 molar. So, 3x will be equal to 0.75 molar. 1 minus x is equal to 0.75 molar, 1 minus x, and 1 minus 2x is equal to 0.50 molar. Clear? Now, Kc is equal to C to the power 3 D upon A to the power 2 and B. This is the expression. Now, C to the power 3, that is 0.75 to the power 3, and for D, that is 0.25 upon, for A square, that is 0.50 square, and for B, that is 0.75. This is the expression. Now, check out which is the correct option here. That is 0.75 into 0.50, that is B is the correct answer. Clear, friend? This question seems tough, but if you have guts, if you have solid theory, you can solve such kind of question. Actually, in NEET examination, 1 or 2 questions are asked from this chapter. This is completely calculative type, and questions are like similar pattern what I am discussing. You have to find out the relation between K1, K2, you have to find out the value of Kc, you have to find the value of Kp. These are the questions. Clear to you? If you follow these questions, then you can definitely solve the question from competitive examination. Wait for a moment. Let's move to the next hurdle. Now, next one, question number 6. The equilibrium constant for the homogeneous reaction. Okay. what is given here? This is completely calculative type, the equilibrium constant for the homogeneous, that is Kp is equal to 10 to the power minus 3. We have to find what is standard Gibbs free energy, that is delta Z, clear, and temperature is 27 degrees Celsius, that is 300 Kelvin, clear, and R is here 2 calorie per Kelvin per mole, but the answer is in kilocalorie, so better to write here 2 into 10 to the power minus 3 kilocalorie per Kelvin per mole, clear. This is the data. Now we people know delta G, as I discussed in my theory lecture, delta Z is equal to minus 2.303 RT log Kp. Remember this, minus 2.303 RT log Kp. Now put the value 2.303 into 2 into 10 to the power minus 3. Clear? What is the temperature? 300 and log Kp 10 to the power minus 3. Clear? Now what will happen? 2.303 into 2 into 10 to the power minus 3 multiply by 300 into minus 3. Log 10 equal to 1. This is the log. Now this one cancel this one. That is what will happen? 2.303 into 2 into 3 into 10 to the 3 into 3. 3, that is 3, calculate 2.303 into 2 into 3 into 3, okay. Now 10 to the power minus 3 into 10 to the power 2, this is 3 into 10 to the power 2. Now solve this. 2.303 18 into 10 to the power minus 1, clear. This is the expression. Now how to solve? 2303 upon 18 upon 1000, if remove point, multiply by 10. If you solve this expression, then definitely you will get the answer. It is around plus 1.454 kilocalorie. Clear to you? This is the answer of this question. This is a simple question related to the relation between delta G and Kp. Now let's move to the next question, next expression. Question number 7. The vapor density of fully dissociated NH4Cl would be, as we know, if dissociation take place, it will break like this. NH4Cl, that is NH3 plus HCl, or sometimes it can be written like this, NH4 plus and Cl minus. This is the expression. And if dissociation take place, then definitely it will have the less vapor density. So in this case, what will happen? Less than half of the vapor, less than half of the of pure, no, double, not possible. Half of the vapor density of pure, because this is 1 mole, now it converted to 2, just double, so vapor density will be half. This is the theory based question. Remember this, dissociation 1 complete, now dissociate into 2 part. So if it has density x, now what will be the density? That is x by 2. 2 part dissociation. If 3 part, that what will happen? That is x by 3. If 4 part, that means what will happen? X by 4. If 5 part, what will happen? That is x by 5, and so on. Clear to you, friend? Now I am going to rub this part. So for this, C is the correct option. So for this, C is the correct option. Half of the vapor density of pure NH4Cl. Now let's move to the next one. Now variation of K, Arrhenius equation, extension of Arrhenius equation. Do you remember this? Now it's your turn, you have to solve. I have derived the formula. As we know, the value of K changes with temperature. Look at log K2 upon K1 is equal to minus delta H upon 2.303 R upon T2 minus T1 upon T1 into T2. That is the expression T2 minus T1 upon T1 into T2. So this, if I check this one, look at minus delta H upon 2.303 R, 1 upon T2 minus 1 upon T1. Clear to you? You can also write like this, 1 upon T1 minus 1 upon T2. Look at this A and this C have similarity. That is the only the minus sign here varies. So during solving the question, check out each and everything very carefully. If I use this one, that it will be equal to 1 by T2 minus 1 upon T1. No, the expression is 1 upon T1 minus 1 upon T2. But if I enter this minus sign here, but if minus sign is here, then 1 upon T2 minus 1 upon T1. Clear? So for this, C is the correct option. Clear to you? This is the theory base. In NEET examination, the question does not come from harder topic. It just it based on simple tips and techniques. Clear to you? Now this is a very good question. I have included this question from my side, that is CaCO3 CaO plus CO2. Clear to you? For the complete decomposition of CaCO3, the temperature in Celsius, that is we have to find the value of T. If there is complete dissociation, then what will happen, friend? Tell me. That is Kp is equal to clearly 1. Kp is equal to clearly 1, complete dissociation, that is log 1 is equal to 0. So put this value, that is the expression log Kp is equal to 7.287 minus 8500 upon T. Clear? As we know, for complete dissociation, Kp is equal to 1, that is 7.287 minus 8500 divided by T. Clear? This will be equal to 0. 0 is equal to 7.287 minus 8500 upon T. Clear? Now 8500 upon T is equal to 7.287. Am I right or wrong? Bill, sir, you are absolutely right. Now what will happen? T is equal to 8500 upon 7.287. After solving this, you can easily get the answer. In this case, what is the expression of Kp? Kp is equal to partial pressure of CO2, because this one is solid state, this one is solid state. So for writing the expression for Kp, that we will consider only the pressure of CO2. If there is complete dissociation, decomposition, that is Kp is equal to 1 and log 1 is equal to 0. If I solve this expression, then we'll get the answer 894 degrees Celsius. Clear to you? This is one of the best question. Now let's move to the next one. Wait for a moment, friend. Give me a few seconds. Now the next one is XY2 initial pressure. Let me once write down the expression. That is XY2, which wait for a moment, which gives you XY plus Y. Clear? The initial pressure, that is T is equal to 0, that is 600, and this one is 0. The total pressure at equilibrium, okay, T is equal to T equilibrium, put here 600 minus X, and this one is X and this one is X. Clear to you? And what is the expression? Total pressure, tell me what will happen. That is total pressure, that is 600 minus X plus X and plus X. This will cancel this one, and total pressure is given 800. This is the expression 600 plus X. So X is equal to 200. Clear? Now write down the expression for Kp for this expression. Sir, Kp is equal to X into X upon upon 600 minus X. What is X here? 200 into 200 upon 600 minus 200 equal to 400. Clear to you what I'm telling? 600 minus 200. This one cancel. 2 2s are 4 and this one is 100. Kp is equal to 100. Clear to you? Kp is equal to 100. So in this case the option is B. Clear? Look at the expression again. 600, that is 0 and 0, t is equal to t 600 minus x into x into x. If you put total pressure given according to the question 800, so what will be the value of x? Now if write the expression x into x divided by 600 minus x, this is the general question. So friend, if I talk about the chemical equilibrium and ionic equilibrium, the question related to acid and base. If you have mind that sir you didn't take the question related to acid and bases and salt, I will take the question of acid, base and salt in separately. Separately I will discuss about acid, bases and salt. I have just taken the calculative part of the chemical and ionic equilibrium because maximum number of questions are from this from calculative part for this chapter. Clear to you? Simple question. For the again I am telling the question is from Kp, the relation between Kp and Kc, the expression for Kp and Kc, then the expression for delta G and Kp and Kc. These are the simple question. You can easily solve such kind of question if you have command over the theory. Clear friend? So this is the last question of today's lecture. We will get back to you soon. Thank you so much. Bye bye.